Hello and welcome to Decode Bytes. In this tutorial, we are going to talk about delegates through the eyes of senior developer. You will not just understand how to write delegates, but also you will apply them with real-world examples. So, before diving into details, I want to mention that before creating this topic, I did a little bit investigation on YouTube, and I find that there are tons of videos related to delegates in C#, but unfortunately 95% of them just nonsense, because they are trying to just explain what is delegates with unsuccessful examples. It is really hard to gain this information and apply them to the real world practice. So for me, the problem here is that in the programming, it is 50-50, so you should understand the programming elements, but the other important thing here is actually to understand when to apply them. Most of the videos just explain what is delegates with unsuccessful examples like program one, method one, I don't know, the full class, and etc. And there is no value explaining this topic using these examples, because the problem here is you will not understand when to apply them. But I'm here and I will help you to not just understand what is delegate, and you will understand when to apply them. So let's get started. First things first, we have agenda. We will learn why delegates, and at the end I will show you the real-world examples of delegates. Actually, I'm planning to have 2 videos related to delegates. This video will help you to understand delegates, apply them step by step, and the second one, from the senior's perspective, you will understand when we are applying them, and you will understand in which type of design patterns actually uses delegates. Let's get started. I've prepared a simple example for you here. It is actually the real-world example. We have a database application. It is actually a console application, and I have isolated us from the other complexities like writing repository services and etc. It is not important for us. We are just focusing to learn delegates. I have DB context here. I have customer and cards. For the customer, we can have multiple cards. For the customer, we have customer ID, name, address, and cards. And we have a toString overridable method to override the customer information to see directly customer in our console window. The same applicable for the card also. And also we have multiple attributes for the card, like holder name, expire date, number, and the exact customer information. Now I have one single method here. This is called getCards. We need to refactor together this method to make it reusable and extensible. Let's do it together. Right now we have getCards methods. Actually, the signature is wrong because we are getting card information from the database. We are checking if the customer ID is equal to 4, and if it is, then we are adding it to cards collection. The problem here is that the signature doesn't indicate that we are going to get the customer ID equal to 4. So you need somehow change the signature, and let's change it. Get cards by customer ID equal to 4. Really sad to see this type of methods. Actually, there is no value of using this method because we are strongly attached to the implementation customer ID equal to 4. We need to somehow add, as I said, reusability, extensibility to this method. Let's see what is the percentage of the reusability in our case for the current method. So I have for now, reusability extensibility diagram indicates that I have 0% of reusability for my method, because my method actually depends from customer ID 4. How can I refactor it? Of course, I'm just going to copy this to compare with the previous example, and I want to isolate my magic number from my method to make it a little bit reusable. And I'm going to create an argument for it, and I'm isolating my method from the magic value. Now my method is a little bit reusable, so get cards by customer ID, and I can provide customer ID from the argument. let's try to call it guest customer by ID, and I want to call customer ID equal to 4. Let's see if it will return customer ID 4's card information. Cool. Now we have 2 rows from the database, and they indicate that we are actually getting customer ID equal to 4. And let's change it to 3 and see if for the 3 we will return any value. We'll get any value. Actually, yes, everything is working quite well. Now let's try to estimate our reusability. Okay. For now, our reusability is equal to 25. We are trying to gain 100% reusability, and our main acceptance criteria here is to get card information, by any value. Actually, what I mean, we have in our card, we have holder name, expiry date, number, card ID, and I should be able to get card information by holder name, by expiry date, by their number, by customer ID. And of course, from the customer ID perspective, I should be able to get customer ID greater than, equal to, higher than, less than. Unfortunately, right now, my method doesn't allow me to apply this type of business requirements. But how I can gain these values? The important thing here is right now we should concentrate our mind to somehow isolate this part, actually, because we isolated our variable, but right now I need to somehow isolate my whole if condition. Okay, my if it is possible for me to isolate this if condition from here and make it as an argument and somehow rename this, provide this argument here, let's say it is ABC. From the argument, I can provide any expression to my method. Let's call it as ABC. This is just a pseudocode. Okay, I'm just trying to imagine how it would be possible for me to isolate this expression. So we know how to isolate the magic values to the variables, but now it is time to isolate the whole expression from our method, because otherwise it will not be possible for us to use to implement our business requirements. Of course, in this case, if you want to isolate some expression from your method, it is possible doing it only with delegates. Cool. Now it is time to understand our delegates. Okay, we have magic values. We encapsulated it using variables. Now it is time to isolate our expression here and make them reusable. Okay, I have a customer ID and I have a customer ID variable here, and this expression returns Boolean value. First things first, before applying delegate, please try to implement your method as easy as possible. Okay, when you reach the senior level, you will easily grab all the expressions without applying the easiest implementation for your method, and it will be really easy for you to encapsulate these expressions using delegates. But for now, try first implement your business logic as easy as possible. After then, try to apply design principles, design patterns, delegates, I don't know, the other cool stuff you want to apply. Okay, let me just copy this method. I'm going to create it, it is third version with delegates. Okay, to apply delegate, you need to understand that delegate encapsulate the whole method, the whole expression. What is expression? In my case, I have this type of expression. Okay, expression is a phrase which contains some type of business elements, the business operations. In my case, my business operation is customer ID equal to customer ID. So in my case, let's try to create a delegate. I will use public delegate. We have a special keyword called delegate. You need to indicate what type of values your delegate will return. For me, I want to encapsulate this if part. So my delegate will return Boolean value. Okay, let's call it my customer delegate. Okay, customer delegate. So my customer delegate returns Boolean value, but what type of arguments it should accept? In my case, I'm just checking the customer ID, and it is in integer type. So in my case, integer customer ID. Cool. Now we have delegates. Let's try to use it. From the arguments, I am providing my customer delegate, and it is possible for me to provide, let's just cut this, type customer delegate. It will accept customer ID, okay, and card.customer ID. Okay, I am providing the logic to my customer delegate. I am encapsulating this expression possibility to my delegates. I am actually delegating it. The exact name of delegates comes from delegating some type of functionality. Okay, and now let's try to understand how to use this delegate. Okay, cool. We have get cards by customer delegate. This is not a good name, but anyway, for now it is enough for us. Let me just comment it out. Var cards equal to get by customer. Okay, I am providing customer ID 3 and I need to provide customer delegate. The delegates are actually classes. In C#, delegates acts as a pointer in other programming languages. They are pointing to exact method to be executed in the future. So our future method will be integer. Our method accepts integer, returns Boolean. So you can easily create this method. Your method should return Boolean. Get customer higher than. Okay, and let's try return. We have in our signature, we have customer ID. Let's provide customer ID. Okay, return customer ID higher than, let's say it is 4. Okay, I'm just providing, okay, let's say it is 2, because the 4 is the last number in my database. Okay, get customer higher than. Cool. Now we encapsulated the ifs logic here to our delegatable method. Okay, you extracted the exact expression from here, and you provide possibility for your user to provide expression outside of your method. This is the actual point of using delegates. Okay, let's try to see if everything is working. I'm just running this method and checking if everything is working. Okay, we have 3 and 4. They are actually higher than 2. Okay, don't take this argument into account. We will refactor it in the future. Now, it is important to focus, because if you are providing some value from outside, you actually don't need this argument. Okay, let's just remove it. I encapsulated my variable and expression to my delegate. The problem here is if I want to create customer ID higher than 3, higher than 4, or these delegates will help you to use not just higher one, but least one. Yeah, that's really cool. Let's see, it should return 1, 2, 3. Cool, we have customer ID 3, 1, 2. Now, you get the idea. You're encapsulating your expression using delegates, okay? The problem here is I actually don't want to every time create this type of methods here. I can use lambda expressions or anonymous methods in my case. It is actually really easy for me to use lambda expressions. So for not every time to create this type of signature, just use lambda expressions. So for your lambda, if your method accepts some type of value, it is our customer ID, you are providing X for it, and you're providing X less than 4. So this expression is actually equal to this expression, okay? You are named your customer ID. If you want, you can just call it customer ID. It depends from you actually, but for the lambdas, we are always using a single symbols like X, Y, and etc. Okay, let's try to see if everything is working. It should return all the customer IDs less than 4. Cool, everything is working. I can easily remove this. Cool, sounds really interesting. And lambda expressions allows you to remove the delegate signature completely. You see, we have moved our expression from if to our method signature. Yeah, this is really important. Cool. Now, using delegates, it is possible for us to provide customer ID higher than given number, less than, equal to, equal or greater, and etc. For example, equal or greater to. Let's try to see. 2, 3, 4. It should return for customer IDs. We have 2, 3, 4. Cool. Now let's try to estimate our reusability. Wow, reusability is equal to 75. Now it is possible for us to do any operation with customer ID, but actually our purpose is to not just work with customer ID, but also work with other properties of card information. Let's try to refactor it again. I'm just going to copy this method from here, paste it here, and I see that in my for each, I already have access to the card, okay? And my card delegate accepts customer ID because it is integer acceptable. How I can modify it to accept card information? It is really easy. Just let's copy this, paste it here. Let's call it customer card delegate, and we'll accept actually card information rather than customer ID. Now for our delegate, we will use customer card delegate, okay, and just provide customer for it. For you, if you are applying delegates in your practice for the first time, try to implement, as I mentioned, as easy as possible, and then try to refactor your code forward to delegates, okay? Now my delegate will accept the complete card information, and from our delegate, I will define which property is actually important for me. Cool. Now let's try to go to the method get cards by customer card delegate. Let's rename it. And in my case, I have full card information. I am defining it as X and X dot cool. I can use customer ID. I can apply holder name. I want to be holder name to be Mr. Thomas. It is up to you. Depending from your business, you can apply any of the logic. So I want to check my customer ID higher than 3. Let's try to see it. Cool. Okay, I will take Hanmabaki from here. I will apply holder name equal to Hanmabaki. Let's run it. Great, everything is working quite fine. Okay, now we did additional refactoring, and let's see our reusability extensibility diagram is equal to 100%. From the real world example perspective, I think now it is a piece of cake for you to understand delegates, because we applied it to our real world example, so it should be really easy for you to understand it. The last thing related to delegates, in most cases we are not creating this type of delegates. Actually, Microsoft has quite well predefined delegates for us, and the most used ones are Func delegate, action delegate, predicate delegate in these scenarios. So if your delegate should return some information, you should use Func delegate. If you have non-returnable signature, use action delegate. If you are exactly returning Boolean value but you have generic type to define, use predicate. I will use Func and predicate in my scenario. Okay, let me just remove all these delegates. I'm just commenting it out for now. Now I don't have customer card delegate, so how to deal with that? There is no need to create it, just use Func delegate. Okay, in 99%, the provided Microsoft delegates will be enough for you. Don't try to spend time to try to apply your own delegates, because in best practice cases it is important to use the built-in behaviors rather than applying your own. Okay, there is no need to invent things from scratch. So our Func delegate, let's try, it has out parameter. It means what type of argument it will return. But in my case, what I have card information as an argument, and I need to return Boolean value. Okay, let's call it predicate, and we'll change it to predicate in future. Okay, now I have a predicate. You see, everything is working without any changes because my Func returns Boolean, accepts card information. Cool. Now I'm running the method again. Everything is working without any issue. Cool. But in this scenario, if you have Boolean response, but you need to define another type, please use predicate by Microsoft. Okay, it is just card because by default predicate returns Boolean value. This is a default signature for predicate. Now, without any changes, everything is working quite fine. In general, you should understand that delegate is a box for your method. You are putting your method to the delegate and you are using your delegate in your method. In my case, let's explain it again. We have here in this method get cards by customer delegate, we have a predicate. We don't know, from the first glance, we don't know what type of logic we are planning to use, but we know that we will have a logic, but we don't know which logic to use. So we are encapsulating this logic to our delegate, and we are providing delegate to our method, and we are providing, it means you have a box inside your method, and to this method you can, to this box you can put any method you want if this method is in the same signature with your delegates. Cool. Let's try to understand real-world examples of delegates. Link queue uses delegates almost everywhere. We have a cool link queue mechanism. It has one interface, multiple implementations. In most cases, you see, I think you already know we have this type of methods here. Let me call them card start where, card start first, I don't know, the last. These extension methods are actually delegates. They are using most of these methods, 99% of them are using delegates. Okay, you can easily create your extension methods. By the way, if you want to learn extension methods and apply this logic with your extension method knowledge, please watch our videos on extension methods, and I explain it from the senior perspective how you should apply extension methods in your real world projects. Okay, cool. Multi-thread asynchronous programming, you have tasks, you have thread classes, and any other. In most cases, most of classes in multi-thread asynchronous programming environment are using delegates. We have event handling with delegates. We have strategy patterns simplified. You are using interfaces in most cases, but if you want to not store some state, if you have only one executable piece of information, you can use delegates instead of interfaces. And most design patterns are using delegates behind the scenes in our C#, modern C#. So I have another video tutorial related to design patterns and the real world example of using delegates from the senior perspective. So please watch and don't forget to subscribe it. Cool. That's all. See you in the next tutorial.